Оу, нет.
Манька.
Не по моему вообще. По-моему, я бы лучше... И вроде все всегда так же. Все так же чашки, ложки. Все та же в кране вода. Все тот же суп из лука.
Кислотный аккумулятор Альпа-Баттери FB 7 февраля 2012 года.
Оу, нет.
12V7.2H, 12V7.2 для детского электромобиля и БП аварийного освещения.
Мне страшно, но спасибо.
Кассовых терминалов, весов, ГПС оборудования.
Балдеж вообще. Это такие инструкции были в олдовых играх, чуваки. Мы покупали картридж для Сеги. Открывали черную коробочку. Кстати, не все застали, потом же стали делать. Сначала стали делать маленькие коробочки черненькие. Первые пиратские картриджи на Сегу, например, они были размером как американки. И внутри там были даже прищепочки, в которую должен был вставать мануал, вкладываться. Потом стали делать маленькие коробки, а потом, я так понимаю, от коробок вообще нахрен отказались. И одни карики продавали. Опять делает вид, что old. Спасибо за стримы. Спасибо, ребят. Спасибо большое всем. Очень рад вас видеть. Какой-нибудь на выходных какая-нибудь теледичь будет, опять же. Так, какая тут мне нужна информация? Добыча сокровища. Баба-баба-баба.
Стримлер, привет тебе от детей батарейки из того самого не видая про кружку.
Нет, это не те батарейки. Та была плоская, но спасибо. Да, слушайте, это реально меня подвели батарейки из фикс прайса. Я даже шутил, что они солевые, они типа алкаиновые. И они норм должны быть в теории. Так, ну пока все нормально, как бы. Это те все-таки не души. Кто украл вообще сундук? Кто пил из моей чашки? Никто не писал спасибо за стримы. Ну, хоть за что-нибудь спасибо. Я могу, ничего я не могу вообще. Ничего я не могу. Ну, короче, ребят, супер казуальный враг. Он пока чарджит, мы просто вообще... Не успевает телеграфировать атаку. Это те не 50 анимаций, блин, на первом же враге у гребаного Миядзаки. Сидел бы дальше, рисовал свои мультики, гребаный Миядзаки. Очередная провальная игра. Нормальные пацаны тут залисят вообще. Палкой бьют, блин, сопли. Так. Но мы не можем. Вот чтобы сюда пройти, это уже элемент Metroidvania. А, кстати, я не знаю. Возможно, вот эти вот маленькие деревца. Нам нужен либо топор, либо меч. Ага, ну мы можем сюда. Что по подземельям? Сейчас мы все про него узнаем.
Не был на твоих стримах. Недавно вернулся.
Полтора года.
Да, там был. Что-то вокруг все сильно изменилось. Цены выросли. Люди какие-то озлобленные.
Да.
Что случилось?
Масляков из КВН ушел. Но все обязательно наладится, а мы пока сходим быстренько проверим Восточный лес. Спасибо, спасибо. Доходят ли донаты? Доходит. Я даже там напрямую переподписался на карту, поэтому получше стало. Так, нет, ну, в принципе, соплюха... Ну, соплюха чисто туториальная, конечно. Сказал я, и, возможно... А мы можем так драться, мы можем даже на них не фокусироваться. На такой мелочевке. Такой мелочевке. Кэш. Угу. Это какой-то троллинг. Ага, ну запомнили. РБ зелье. РТ щит, кстати. Щита нет. Верни.
Ну вот, я сижу на 120 кусков и по сути нихуя не делаю. Такой вот чисто мидл. Свалить куда-нибудь в Германию, но там сеньор нужен. Эх, грустно.
120 тысяч долларов в месяц? Дайте денег, программисты. Ага, ну 3 кнопки понятно. Ага, тут еще инфа. Угу. И это еще и джуниор. А, нет, middle. А, middle, потом senior, да. Senior это у нас... Хорошо. Бла-бла-бла. Есть кувырок. Зажми.
Okay. The entire. So whenever you remove that, the exception being like we just talked about from the frame and showed it there, and you can see that in the teaser for the Glock trigger guard, which is no fun because it makes the frame. Okay, here we go on part 2. Of course, just normal Dremel tool operation, run across the top and Dremel everywhere. And if you got one of those pieces in your eye, you wouldn't be able to see. And that would tapped off of earlier. There was plastic up right up next to them. Alrighty. America, which is made in China, of course. It's a M2.5 tap that comes with a 2.05 millimeter drill bit. And so, for those of you who don't want to do the English conversion, there's the English size on a caliper readout, a decimal caliper readout. So if you have a drill bit close to that, you want to drill as straight as you can, and you don't want to wallow them out too much. Okay, so what we're going to do here, speed up the footage just a little bit, is I found that it was easier to do this whole assembly if you just ran the tap through these holes in the frame. Now, the reason I'm doing that is not because we want to like have the screw thread in to the frame itself, because not only would that make it difficult because you'd have to time the threads in the frame to the threads in the rails, but because you don't really need the screws to hold on the inside of the frame, you just need the screw to pinch the rail to the outside of the frame. So it's not imperative that the screw is threaded in, as well as you don't want holes. You're probably as far as how tight to get the screw, one thing going to cause the seat there is as flat as it can be until you get all the way to the. Okay, and so once we've got both of the rear rail sections in place, we are now ready to test the slide fitment. So with those little towers there behind the locking block that we had dremeled the tops off of before, it may come, depending on how accurate you get your rail. So you'll see now when the slide goes on, there's no resistance at all. It goes nice and easily. And so now whenever I get back here to the rear rails, it is dragging on the plastic there at the top of the frame. So what it looks like I'm hitting the rail, but I'm not there. What I'm doing there is removing the plastic at the top of the frame, maybe just the first layer that had sagged out there. With these stainless. And as a note on this mag, just making it so it's a usable gun. So rack the slide vigorously to make sure that isn't going to be an issue for you. On this frame here, I didn't. The pin for this had come out on its own and driven in. That can hold a simple pin in place as if it was a roll pin, just because it has the added friction, added width that the notebook. The tutorial that will be more important to you, how it is that everything goes together. Of course, if you have questions, refer to the README, watch the video a little.
will check it later. Let's unscrew the grip screw with a screwdriver. The barrel, Derringer on plastic. Oh, let's unscrew some parts a little bit later. Here, this is the spring. This is the pin of the hammer. Let's take it out. Yes, that's it. The hammer nose with the cam. It's interesting, but we've made very close, and the spring on the hammer can be disassembled. Let's check it. Yeah, that's it. Now in the program World of Guns, links are in the description. New models soon. New 3D printed models. Bye bye. We'll free some space for this assembly. This is our future model. We will feature cylinder is blocked properly. You may see special grooves here, and I also set the revolver on the safety. Just strip it.
Hey guys, Balakik here, and this is the G22 Grizzly. The Grizzly is a 3D printed 22 caliber break barrel survival rifle. First and foremost, this was not designed by me, but by a guy named Mussy, who's a large contributor to the 3D printed firearms community with the Wait Forward and GunCat Ideas groups, along with literally hundreds of his own designs on Thingiverse. Now the G22 really caught my eye for being a simple but very versatile platform. Almost the entire thing is 3D printable and functions using a simple break action and lock, with a striker that uses a compliant trigger mechanism similar to my own PG-22 designs. This allows for some fairly interesting pistol designs, but the Grizzly survival rifle really caught my eye as I had always wanted a compact folding survival rifle. Hey guys, Balakik here, and this is the P22 Aurora. Like my other designs, it's intended to be mostly 3D printed, while using a limited amount of off-the-shelf metal parts to make it work as a practical firearm. The only machining required is to cut the barrel to length and ream a chamber, along with trimming some 3mm steel rod, which means it's much quicker and easier to build than my revolver. It's also much larger than most of my other designs, being scaled up by about 1/3 from my older frames. This design uses a single-shot implementation of a straight blowback action. To ensure the spent case gets ejected properly, a fixed guide rod is angled so as the case moves backwards, it's knocked sideways and away from the action. I intentionally kept the design single shot only. There's no method for attaching a magazine without a complete redesign. The trigger mechanism blocks any feed area directly below, with the grip being offset completely behind the working components. This design also incorporates a safety into the slide. It's got this small button at the rear of the slide, and it works as a cross pin to prevent the slide from going all the way forward. That way the primer can never be set off by the firing pin. For this build, I printed much more slowly, with thinner layers. Total print time ended up being around 30 hours. Once all the parts are printed, I prep and clean them up a bit. The smaller hole on the breech face is drilled out with a 5/64 inch drill bit, which I'll later use as our firing pin. Any sliding surfaces, such as the sear and trigger, should be sanded smooth. The halves of the frame are sanded to ensure that they're truly flat. This will help hide the seam in the frame, as well as make things line up a bit better. I'll then temporarily screw the frame together and use an 8mm or 5/16 inch drill bit to ensure the hole for the barrel is sized correctly and perfectly round. Finally, I sand and prep the grips. I print mine using a wood PLA, and I experimented with using stain to give it a nice finish, to fairly good effect. Actually, I highly recommend trying this. These things turned out great and almost look like real wood. Next, I work on preparing the metal parts. The barrel is a piece of 22 caliber rifled barrel liner, which can be cut to about 72mm using a small diameter pipe cutter. To ream a chamber, I use a No. 1 wire drill bit, working slowly and carefully, using plenty of oil. I'd highly recommend a bench vise if you have one, as that works a lot better than what I'm doing here. One of the bolts that holds the frame together needs to be cut a little shorter, down to 22mm, which I'll do with a rotary tool and cut off bit. The firing pin is made from the shank of a 5/64 inch drill bit, cut to between 10.75mm and 11mm in length. The tip is then chamfered to a chisel point, leaving a flat face of about 0.75mm width. The last parts required are some 3mm rod cut to length. The guide rod is cut to 74mm with a 45-degree angle cut at the tip, and another piece of rod is cut to 30mm in length, and this will be for the slide's crossbar. All of these metal parts add up to quite a bit of mass. To comply with the Undetectable Firearms Act, additional blocks of steel are added to bring the total metal to a whopping 5 ounces, more than enough to be considered detectable. The additional weights are epoxied into the grip area, ensuring they're permanently attached to the frame. The trigger assembly is installed into one half of the frame. The sliding surfaces are lightly greased with plastic-safe grease to provide a smooth and light trigger pull. Here I'm using 0.5 by 4 by 15 mm springs, but a cut ballpoint pen spring could easily be used as well. Next, the barrel is aligned and installed into the frame. The 22 case should be flush with the face of the frame. Proper alignment is required for good primer strikes and proper head spacing. Once everything is properly aligned, I can then close up the frame. I press fit the nuts into the left half side of the frame, and then I add the screws to the right half. All screws are cap head 30mm M4 screws. Except this one, which I previously cut to 22mm. I'll also use a pair of M4 set screws to help prevent the barrel from shifting forward or backward. But just couldn't really justify the cost of the more expensive commercial models. Unfortunately, the initial mock-up of the Grizzly was a bit too short to be considered a rifle, so I got to work to remodeling the design with a reinforced receiver to support an extended barrel and stock, which are printed in segments and then pinned and glued together. As usual, I printed the stock using wood PLA, which I sanded and stained. The stock also doubles as extra storage for spare ammo. The receiver, striker assembly, and barrel were printed and assembled in standard PLA or PLA+. The only fabricated metal parts used are a .22 caliber rifled barrel liner used inside of the 16.5-inch barrel, along with a small portion of solid metal rod inside the receiver to reinforce the breech. A small drill bit shank is used as the firing pin. I also opted for extension springs on my build instead of rubber bands, which I think looks quite nice. The entire rifle is capable of folding in half, making it very compact. Operation is also very simple, utilizing a brake action with manually cocked striker. While there is no ejector, it's fairly easy to manually eject spent cases by hand. The spare ammo storage in the stock is accessed under a sliding cover for easy access while reloading. So, how does it perform? Well, my first few test shots were quite off, but I was eventually able to get it sighted in pretty well. Mounting the sight directly to the barrel instead of the receiver also allows for far more consistent shots. I also found it to be extremely quiet, due in part to the long barrel and sealed action while firing. I initially fired about 75 rounds through it, and unfortunately had a problem with the trigger cracking after repeated use, so this may be something to watch out for, as PLA does tend to get brittle when flexed too much. I revised the design, adding space allowing the plastic to flex further back, better distributing the force along the length of the trigger. I also added a retaining nut instead of relying on threading a screw through the plastic. These changes should make the design much safer to shoot, and it also greatly improved the feel of the trigger pull. So of course here comes the inevitable question that I'm probably going to get. Where's the STL files? Well, I hate to break it to you, but I don't actually host any of the files that I make or modify, because I just don't want to get into that sort of legal complication in doing so. However, the files do usually end up making their way around the enthusiast communities, so check around as they are out there. I would recommend checking out the Wait For It and GunCat Ideas groups, which are both terrific groups that focus on further research and development of 3D printed firearms instead of bickering about politics the whole time, which is part of why I really enjoy the group. The G22 is really kind of a toy in comparison to some of the new stuff that they're developing, like some of their semi-auto parts kit guns. Overall though, I'd really recommend the G22 in any variation. Again, all thanks goes to Mussy and his brilliant designs, along with everyone else who has tested and contributed to the G22. The design's extremely cheap and easy to assemble, it's fun and accurate to shoot, and can be modified to make it into whatever you want. Well, as always, thanks for watching, and hopefully you found this video educational or entertaining. Before assembling the slide, I'll add just a very thin coating of plastic safe grease to the sliding surfaces on the frame. The 30mm rod is then pressed fit into the hole on the inner wall of the left slide half. 5/16 inch outer diameter spring is cut to a length of 44mm and inserted into the frame. The safety catch should go through the square hole at the rear of the slide, with the tab notch facing to the right and rear. To close up the slide, we'll align the right and left halves, making sure the 3mm rod falls into the hole on the right half side of the slide. Fit all nuts into the left side of the slide, then use M4 by 30mm screws to secure the halves of the slide together. The firing pin is installed next. The firing pin's rectangular face should be aligned vertically and secured into the breech face using a strong epoxy. The firing pin should have about 0.75mm protruding from the breech face, erring on the side of too short. In fact, I found mine worked best at about 0.65mm. Finally, I'll install the ejection rod. This part can be a bit tricky. Apply a bit of plastic safe grease on the guide rod, and with the slide open, fish the rod through the barrel and into the breech face. This is a tight fit as the hole is offset from the barrel, but the rod should have enough flex to fit through. The flat side of the rod should be angled outward towards the right side of the frame, and then secured in place with an M4 set screw. After everything is assembled, I test to make sure everything operates correctly. Finally, I'll install the wood grips. These can be secured using M4 screws, as with everything else. I ended up liking the looks of these grips so much that I went back and added them to the Maverick. Throughout testing, the PG-22 Aurora functioned mostly as intended, though initially I did have ejection issues.
60% of the time, it works every time.
It seemed to eject reliably only with hotter ammo, so I went back and used a slightly softer spring. I was still having the occasional failure to eject, so I also used some rolled up sandpaper to polish the chamber, which greatly improved ejection reliability. Due to the firing mechanism, the whole frame jumps before firing, making it far less accurate and a lot less pleasant to shoot than the Maverick. It definitely does pack a lot more punch, especially with CCI velocitors. So for comparison, here's the aftermath of a 12-gauge slug. Surprisingly, the plastic breech face does not seem to experience much wear at all, even after about 500 rounds, so long-term reliability seems pretty okay so far. Overall, while it does work, it's just not as convenient or as accurate as the Maverick. I'm not sure if this is the right design to follow, and I may actually scrap it entirely.
Hey, thanks for watching this video till the end. If you'd like to see more projects like
Hey guys, Pallet Geek here, and this is the Chimera 410 shotgun.
Hey guys, Pallet Geek here, and today we're going to be looking at, I just pointed that straight at my face. We tried bidding on it, and we won it. It actually was in good condition. I was very happy to find out that it was very well taken care of. Everything seems to be fairly well worn and used, but nothing looked like it was... Hey guys, Palageek here, and this is a very sketchy shotgun. While 3D printing has enabled me to create some interesting designs, I started designing guns far before I ever dreamed of having a 3D printer. This shotgun is the very first homemade gun I ever attempted to build. It's a 12-gauge shotgun built mostly out of hardware store parts with a few salvaged components. On first glance, it actually looks pretty competent. However, on closer inspection, things start to get bad pretty quick. The main construction consists of some aluminum angle stock braced together to form the foregrip and frame. The shoulder stock uses a length of square tubing and some additional aluminum for the butt stock. Similar to a break barrel shotgun, there's a latch to allow the frame to split and rotate, hinged on a single bolt. One of the more clever bits is the use of a snowmobile handlebar clamp to hold the barrel in place. This actually worked out quite well to attach the barrel, and allows replacement barrels or just adjustments to the position. Hey guys, Palageek here, and wanted to let you... we're still this off eBay, and it's actually pretty high quality. I'm just kind of finishing up the ends on that. While the weather is still nice, I wanted to test the effectiveness of slugs in the Chimera. The first shot was taken from around 5 yards. The second shot was taken... Hey guys, Palageek here. Today we're going to be testing out my new revision, the Maverick V2. Parts are checked for fit and sanded if any tolerances are off. All parts are printed in PLA Plus on a mid-range desktop printer. To provide a little bit of extra heat resistance and durability, I print the frame at 100% infill. Large mating parts, such as the frame, were sanded to compensate for any warping which may occur. Smaller mating parts are checked for fit and sanded if any tolerances are off. While a fully 3D printed gun is possible, the addition of a few common metal components greatly improves function and longevity. Commercially available steel barrel liners add proper rifling and provide the necessary strength for the cylinder. The rifled barrel liner is cut into 6 equal lengths of around 44 millimeters. Chambers are then cut using a number 1 wire drill bit before being epoxied and pressed into the cylinder. Next, I cut a few compression springs and 3mm guide rods, which are used for the striker and charging handle. I also cut a 1/16 drill bit and epoxy that into the striker as a firing pin. In order to comply with the Undetectable Firearms Act, additional metal weights are epoxied inside the grips, bringing the total metal content over the minimum required mass. Most of the assembly process is the same as my previous design. Once all the parts are prepped, it's really a simple matter of screwing everything into place. I first installed a spring-loaded ball bearing, then I used a large bolt through the frame for the cylinder to ride on. The trigger and striker assembly slide into the top and rear of the frame, followed by the additional linkage and charging assembly. Once all the core components are installed, I close up the top cover. I slide the guide rods and springs into the rear, and finally add the grips and sights. While I do love the simplicity of the original design, the addition of the charging handle does feel like a step in the right direction. I may play around with the design a bit, possibly making it more ergonomic to grip, as I'm not really extremely fond of the tiny knobs, especially after a lot of use. Accuracy also leaves a little bit to be desired, as any small deviation between the barrels results in a different point of impact. This could be improved by using a more conventional single-barrel design, but I'm not sure how the plastic would handle high-pressure gas vented between the cylinder and forcing cone of a single-barrel design. This also brings up the point of why I don't implement certain features that other guns do, but unfortunately, many modern designs just don't work well with 3D printed plastic. Small ratchets, catches, and linkages, which are easily implemented in metal, just simply are not tough or precise enough to provide reliable functionality when printed in plastic at smaller scales. I believe this is why the development of many 3D printed designs are moving towards a simple printed receiver, offloading all the complexities to unregulated parts adapted from other gun platforms. As always, a warning about safety. A bad print or degradation of plastic over time could lead to a failure. Assembly of a firearm should only be done by those with mechanical knowledge, and it needs to be understood that no matter what, building and firing a homemade gun is inherently dangerous.